In this video, we're going to still talk about section 5.2. We're going to talk about the definitions of relative, extreme, and critical numbers. If you have not paused and read through this page, you should do that first. The graph of f of x equals x cubed minus 3x squared to the right has a relative minimum and a relative maximum. So they tell us exactly where those are at. So right here is the relative max, and right here is the relative min. If it makes you easier to think about, the max as being a peak, so this is like a peak of a mountain, whereas a relative min is more like a valley. Note if the peaks and valleys have smooth rounded curves about them, and the graph has horizontal tangent lines at that point. So what they're saying is we have that smooth curve, we would have horizontal tangent lines here. If we have the jagged, that means that technically we don't have horizontal tangent lines because a derivative, remember, does not exist at a point, a corner. Each relative extreme of the derivative is either 0 or does not exist. So at relative extreme, it's either 0 or does not exist. The x values at these special points are called critical numbers. So a critical number, in official math terms, is let f be defined at c if the derivative at c is equal to 0, or if it's not differentiable at c, we have a critical number. And then relative extreme is official definition. Let f be a function whose second derivative exists on an open interval. If there's an open interval containing some value c, in which f of c is a maximum, so remember this is your x value, this is talking about a y value, then f of c is called a relative max. Basically, it has to just be the highest point in the area to be a relative max. Notice it's the highest point in this area. It's a relative max. A relative min is the lowest point in the area. Notice there's lower points on the graph, but that's the lowest point in that region right there, makes it a relative min. So same thing here. There's an open interval containing some x value c on which some y value f of c is a minimum, then f of c is called the relative minimum. The plural of relative minimum is relative and relative maximum is relative maxima. The plural of relative minimum is relative minima. There's some examples of critical numbers. We know that the derivative doesn't exist there because it's a cusp, but it's still a critical number. Here, we've got a horizontal tangent, so that's a critical number. Officially, f is a relative minimum, relative maximum, x equals c, then there has to be a critical number of f. So you can't have a relative extrema without a critical number. So the way that we kind of remember these things is out in the left-hand column. So let's write those down really quick. So a critical number is the x value where the derivative equals 0, because at a horizontal tangent, you're going to have a 0 slope, or is undefined. And remember, we can write undefined as does not exist, DNE. A critical point is the x and y value found by plugging into the original equation where the derivative equals 0 or is undefined, which does not exist. And then finally, another name for a critical number is a point where there is a horizontal tangent line. So horizontal tangent line, critical number, derivative equals 0, those all mean the same thing.